But it also comes down to like what kind of volumetric flow rate are you trying to achieve. If you need very high top speed, you got to feed a lot of filament fast, then you can't really go too high on it. We want as little weight on the tool head as possible, and then a geared setup is pretty much, you get more precision with a 0.9 degree stepper for sure. The price you pay is that and with LGX gears, we have found that we kind of have a little bit too much. So our motto is reliable extrusion. So if we kind of have to sacrifice a tiny bit of then I guess so be it.
Well, welcome to the Engineers Grow podcast, a place to learn how to design cool machines. I'm really excited for today because this is the very first podcast, and we have a very great guest today. Hopefully I won't butcher his name, Olof Ogland. He's from Bondtech, and we're going to be chatting all about extruders. For those that don't know me, my name is Andrei Salfinnikov. I've been a mechanical engineer and for the last 12 years and have been enjoying designing a lot of cool machines. And this project, the YouTube projects, kind of lets me explore other machines that I don't get to design at work. So with that, Olof, thank you for joining us on the podcast. How are you doing?
Thank you. I'm doing great. It's pretty cold day here in Stockholm. But no snow has come to wreck the local traffic yet, so it's all good.
Nice. At your place, if it snows, are people pretty much prepared for it, or?
No, it comes as a surprise each year, I would say.
Because here in Vancouver, Washington, if it snows half an inch, the whole city shuts down.
Yeah, same here. Even if we're up north, it's pretty much the same.
Okay, wow. Cool. Well, once again, thanks so much for joining on. And also I want to say thank you to Bondtech for being supportive of the project. And this whole new chapter in the Engineers Grow YouTube channel, I feel like Bondtech had a very big impact on that, because originally I reached out with a different ask of, asking for an extruder as a sample. And then you guys proposed I do this idea instead. And you guys were very open to it, and we were able to communicate back and forth a little with the early concepts. And even though kind of what I'm developing is a competitor of what you're doing in some sense, but I don't see it that way because, I'm more on the educational side than a hardware side on this project. So thanks so much. I appreciate that. So let's go ahead and get started with question one. Maybe for the first question, you can just give us a little bit of background about yourself, how you got started at Bondtech, and just overall career. What have you got to do in the past, and some of your experiences that you're excited about.
Yeah, for sure. So I'm originally like a community member, more or less. I was one of the, founding admins of one of the largest Prusa Facebook groups called the Prusa Community Forum.
Nice.
It took off pretty fast. We got like 17,000 members within the first year, I think.
Wow.
So I was like super active there and took part in like doing the community mods and all of that stuff, because obviously I want to improve what I got, right? And that platform is, it is that at its core, improving modding and stuff. So Bondtech eventually put out the message that they were doing like an extruder upgrade for the system, the Mark 2.5, Mark 2S even, I guess, and Mark 3. So I jumped on that pretty fast, put together a focus group with like my connections from the community, because I wanted this to be like the best it could be. Mm-hmm. And that's like how the communication started with me and Bondtech. A bit further down, when the Prusa Mini released, I asked for like the source files of the BMG extruder, and I made my take on an upgrade kit for that, and that became like one of our most selling upgrade kits of all time. So the path from that to being actually hired by them wasn't that long. Yeah. So that's pretty much it. My background from before this is primarily within like product photography, more specifically jewelry. So
Mhm.
that's what I've been doing for like a long time. So it's all started as a hobby, but yeah. And I mean, even now I'm doing a lot of media production and product photography as well. So aside from the product development side.
Oh, that's pretty sweet. So the 3x1 concept you came out with, is that the one that Bondtech kind of took over and made their flagship for a while, or is it
No, not really.
that?
More like I took that flagship and integrated it into the Prusa Mini.
Oh, the other way around. Okay.
Yeah, the other way around.
Okay, cool.
Sure. Yeah.
Nice. Well, that's exciting. Sounds like it's pretty cool to see when a passion becomes a job. It's like, and for you, that's a pretty big, difference, I would say, is to go from.
Yeah, it's really a dream come true, I would say.
Nice. Well, that's I think a perfect segue into the second question is regarding to compare the two different extruder types. There's the 3x1 you mentioned, and then also more recently there's been the large gear extruders that have come out. And so maybe you can describe the two, give pros and cons of each.
So I mean, what we started with was basically Martin in his garage. He had a pretty underperforming printer called Velleman K400. It wouldn't like feed filament properly and so on. So he made his own extruded drag gears for that to solve that problem. If we flash forward a bit, then eventually the V2 extruder came out, and on that he actually used a stepper motor with a gearing stage, a geared stepper motor. So even way back then we used geared extruders to feed filaments, because you get so much more torque for the weight and footprint you got going on. So I guess that would be the benefit, to cut it really short, that the sacrifice we make, the primary sacrifice we make when we apply a gearing stage on a stepper motor is top speed. But we're not really approaching those top speeds in normal extrusions or even ultra high flow extrusions, depending on the gearing.
So it's really a limit that's not really there for us. Like what is kind of like that top level limit?
For instance, our LGX Lite Pro, it has a pretty high gearing ratio, and we can see that it starts to lose a little bit of torque at something like 50 cubic millimeters per second. But it of course can go higher. It all depends on how hard you try to push it. With our slightly more coarsely geared LGX Lite V2, we can easily push up to 100 cubic millimeters per second, assuming you got a hot end that can melt plastic that fast. It's not really the strongest extruder out there, but it can spin fast.
Okay. So aside from, let's say, the top speed, are there any situations where you would still want to use the 3x1 versus the larger gear?
I guess if you're not putting that weight on the tool head and only putting it on like on the frame in case of a Bowden extruder, then I guess a slightly less complex setup where you can eliminate backlash entirely could be preferable. The downside in that case, I guess, would be that the micro stepping on the motor, I mean, the resolution on the motor would be the limiting factor there. But as we all know, in a Bowden extrusion setup, the artifacts from those steps are kind of dampened at the same time. And also another benefit of that, I guess, is less stress on the MCU, on the printer mainboard or whatever board the stepper is connected to, because the amount of steps per second is significantly less.
Okay, but I guess overall, it seems like the industry is moving towards the larger gears, and that's for a good reason. Seems like a lot of those issues that you're talking about have a workaround, or they're not an issue in many printing applications, essentially.
Yeah, I mean, we want as little weight on the tool head as possible, and then a geared setup is pretty much inevitable, I guess.
Okay, cool. Well, with that, wanted to dive into the second question, discussing, single versus dual gear drives. And I believe Bondtech only offers dual gear drives, and like the one that I still have a maker gear. That's my main one, just because I don't print too much for outside projects of the YouTube. And maybe can you just, so I guess there was a video that I think Mirage C put out where he was looking at the disadvantages of that, and how there can be some issues with the tolerances. I was wondering if you can dive into that a little more, that issue, describe a little more. I think I saw in the comments that he actually worked with you guys on potentially making some improvements, and I think I saw a comment that you guys were working on a few things. So maybe you can update on any investigations you had since then, what kind of results were you able to achieve, and just wanted to kind of understand what the real issue is. Is it like just more of a very small surface artifact that maybe like in some special niches that is critical, or is it like a real need that most users need to consider?
I mean, so our motto and the founding idea of the company is reliable extrusion. So if we kind of have to sacrifice a tiny bit of like top print quality, then I guess so be it, as long as the filament feeds right. But what we talked to Olivier about, where he helped us, was with highlighting the actual effect of non-concentric primary drive gear.
Mm-hmm.
So that's so the drive gear on the gearing shaft, on the bigger shaft, if that's slightly non-concentric, then that impacts the surface quality in a pretty visible way and measurable way. And zero tolerance machining is pretty expensive, so we opted to go for an integrated drive gear instead, where we cut the drive gear straight on the shaft it was supposed to be sitting on. So then we got rid of that non-concentricity, basically.
Okay.
Yeah.
Were you guys able to completely get rid of those surface artifacts, or just greatly minimize them?
Greatly minimize them, I would say.
Okay.
I mean, there's still some artifacts that stems from that we have those rounded teeth and the secondary drive gear there, but and we're experimenting with like different kinds of solutions, like straight cut teeth and all of that, and so far we haven't seen enough benefit from changing it all that much, really, because reliability is the number one thing we're trying to achieve here.
Okay. So I think that's all I had for that question. The next question is related to the filament tension mechanism. So I know some extruders have a spring that provides the tension force. Others use a screw head to actually limit the spacing that the filament between the gears that the filament has to go through. So I was wondering if you can talk about those two, to describe the pros and cons of both of the setups, and which setup is ideal for which type of printing application.
So I'm going to bring up some history here again. On the V2 extruder, that was one of the first extruders we released. We actually had a fixed positioning screw on the idler.
Mm-hmm.
So no spring there. Once we released the QR, then we introduced the spring. And I mean, that works great. The only downside, I guess, is that it's not really super repeatable how much tension you set each time. And when you go from like a very hard material to TPU, you might need to relax the filament tension a little bit. So when we developed the LGX, the large gear extruder, we wanted a more repeatable way of setting that tension. So we went back again to a non-spring set filament tension with the lever we use to set the filament tension like this.
Okay.
So it's very repeatable with several discrete locations for the filament tension. And I guess the downside of that is that if you use a filament with a non-consistent diameter, then it can fail to feed sometimes, or even just struggle to feed. So ideally, you should use a pretty high tolerance filament with that setup.
Okay. So basically, the spring kind of gives you a lot of forgiveness in some sense, but it can't really handle the large variation between like soft and hard filaments. And then you have to kind of, I know when I would do it, I would have to, like, with my torques, do quarter turn, half turn, and have those things in my mind, my rules of thumb when switching between like ABS and TPU. But essentially, kind of like your newest one is kind of the hybrid of both worlds, where you have a fixed one because you get more precise control, but then you can easily adjust it.
Yeah, exactly. But the downside with that again is that if you have a out of spec filament diameter, then it can, like, because the tension, right, is relentless. It doesn't like allow for oversized filaments then, because it will be pushed extremely hard by the drive gears. Or if it's undersized, then the drive gears won't grip it perfectly.
Okay, so when you're saying tolerant, sorry, go ahead.
No, I mean, of course, we're developing different kinds of alternate takes on it. Like, I mean, I guess the ideal solution would be not to have to mess with that at all, right? It should just work.
And so when you're saying it's like out of tolerance, like how much of a out of tolerance does it need to be to where it's like you're either over compressing or losing too much grip?
That's super hard to really answer, because it all depends on how hard the filament is. If it's undersized, then I mean, if it's like below 1.7 millimeters, I guess, then I mean it won't work. I mean, if it is that size, the entire spool, then it's no problem. Then you can just set the filament tension a bit harder. But if it's varying across the length of the spool, that's where you run into issues.
And you've seen like just filaments out there that vary enough to cause that, or is it more of a theoretical thing that could happen if you get a spool that's really bad?
I mean, it doesn't really happen if you buy from a known brand, but if you like to buy cheap and buy like B-stock filaments, then that might be a issue you might face with an LGX extruder. Yeah.
Okay. Let's see. Moving on to the next question. Regarding motor size and gearing ratios, I think you already touched on it a little bit earlier. I wanted to kind of get understanding any other issues you can have with like gearing too much for the drive itself. And really, one of the things I'm wondering about is like right now, on the prototype printer that I have with the single extruder concept, it came with a very large motor for the extruder. And I know nowadays the motors are very small with higher gears. So maybe you can talk about what happens when you go to a higher geared. I understand like you can get a smaller motor, but like what about the technical considerations you need to take into account that affect performance, and ultimately, how small of a motor can you go to before it's, in many applications, maybe it's not reliable or it's just too difficult to work with?
Yeah, I guess it all depends on your application. I mean, if you need very high top speed, you got to feed a lot of filament fast, then you can't really go too high on the gearing ratio, because as the stepper motor reaches high RPM, it generates an electromagnetic field. I mean, it's known as back EMF. So it dumps like a lot of current back into the driver, and eventually it just stalls, even if it's not really doing all that much torque-wise. So, I mean, the smaller extruders, they're good, I would say, for more like normal printing, what we're doing with our everyday machines. So as long as it's like not something crazy like an Annex K3 or whatever, then you're probably fine with a pretty small motor, I would say.
Okay.
But if you're going like into ultra high flow territory or like even faster, like above 100 cubic millimeters per second, then something like our LGX is pretty reasonable when it comes to torque at those high speeds.
Okay. Are there any other downsides that you get when you go to a higher geared? Are there, like, I think you might also mention there might be more play involved, and how does that impact the performance of the extruder?
I mean, gearing comes with backlash because either you like make sure you have no backlash, but then it wears out way faster. So you need some kind of backlash in order to have longevity in your extruder. When it comes to like, I mean, for the LGX Lite, we really pushed our components as far as we could while still keeping them the same components. So we use a 7-tooth motor up against a 44-tooth gear. And that means like only one tooth has engagement at a time. So you're really stressing the surfaces on that single gear you're pushing with. I mean, that I guess is the sacrifice we have made when it comes to high gearing ratio. Not that we have seen really any motors being worn out yet, but there's a potential there, I would say.
Okay, and it sounds like, especially if you're trying to drive too fast, or maybe there's a lot of friction in the filament on the way to the extruder, those issues can compound if you try to gear too much and you only have one gear making contact.
And you also put more strain on the MCU, on the printer motherboard, when you generate those very high step frequencies. But I mean, you can somewhat mitigate that by doing coarser microstepping, I guess.
Okay.
Yeah.
What about the 0.9 degree step versus the 1.8 degree step motor on the extruder? What are because I've seen, I think, some applications where they go to 0.9 degrees now. What are the real advantages of that? Do you really get more precision? Because I did a little bit with stepper motors, and it seems like, higher stepper motors is good, or higher microstepping is good up to a certain point until it actually reverses back and you get lower precision. So kind of wanted to understand where we're at between those two.
I mean, you get more precision with a 0.9 degree stepper for sure. The price you pay is that you get less torque for the same footprint and weight.
Okay. Is it like on the order of typically like 15-20%, or is it you've seen a higher reduction in torque?
I'm not sure. I mean, I don't have a precise number, but I would say it's a bit higher than that, the loss.
Okay. Let's see. Well, let's move on to the next question. So in terms of like filament materials, I wanted to know, like, what does it really take to like be successful, let's say printing, let's say very soft filaments? The harder ones are easier, but what does it really take in an extruder to be able to print a soft material reliably over and over again, and with a good enough quality, not like maybe like perfect with no surface artifacts, but to the point where it's an acceptable part for majority of the users?
I mean, for one, you need grip. You need lots of grip. And with LGX gears, we have found that we kind of have a little bit too much grip, maybe. we made them as big as we could in the NEMA 17 form factor, or I guess even NEMA 14 these days. But grip isn't the limiting factor anymore when we use that system, but it's filament constraint. So you need to make sure that the filament can't escape anywhere, because it will if you push hard enough. It will just pop out the side. So that's that's what you need to deal with. And with larger radius filament gears, the possibility for having like a constraint that filament path gets very sharp up towards the end with larger filament gears. So yeah, it's a challenge really to constrain them that much. But another important factor that I don't think is light is shown upon that much is the material itself. Because if the material is, if the material has a good formulation, then it can be night and day. I mean, if you take 185A shore hardness filament and compare it to a really optimized one, you can suddenly get like 3 or 4 times the volumetric flow rate out of the same setup. So my number one advice, I guess, would be to choose your TPU very carefully.
Okay. What about, can you elaborate a little more on, you said too much grip. What does that mean? Is it like over squishing the material, or is it something else where?
We don't really lose grip on the filament before something else happens, like the filament escaping or filament buckling somewhere inside the hot end or something like that. So,
I see. Like you have more than enough design margin to where other issues are the limiting factor.
Yeah.
Okay. What about like, I know we've tried in the past in my work a little with super soft TPUs, like was it 65A Chinchilla, I think it was. And the issue often we would try to print small parts where we needed something nice and soft, but we would print 1 or 2 and then not be able to print it again. And then a few months goes by, we can print a couple of sample, and then when we really need a replacement, it doesn't print. With the larger gears, are they a lot more easy to print the very soft TPUs like the 65A?
Yeah, I would say so, because that filament really wants grip, and that's what we can offer with those large gears.
And does it have any issues with, kind of like you were saying, where it misses the path after the gears and just want to go different places?
Yeah, I mean, if you push it too hard, if you try to go beyond like the limit, then it will escape out the side instead. Especially with those soft filaments, because they can deform so much. So I guess you need to really test the highest reliable flow rate your specific setup can manage, and maybe back down a little bit from that, even if you want to make sure that you're going to be successful.
Okay,
and keep your filament very dry.
Flow rate.
Yeah. And I mean, also one very important thing that is often overlooked is the filament path going into the extruder. You need to make sure that you don't really have a lot of friction there, all the way from the spool holder you're using to any like kind of reverse Bowden filament path. You really need to optimize that for your TPU to make sure that there isn't any high forces required to pull the filament either.
Okay, great. What about like carbon fiber and glass filaments? And I've actually never printed a glass filled filament yet, but I've done a little bit with carbon fiber. Are there any special considerations that are needed for the more advanced carbon fiber or glass filled filaments?
I mean, we actually feed those filaments to the extruders for breakfast every day, and they really enjoy it. So, but not really. No, I mean, it's more important when it comes to the hot end to make sure that it can take the abrasion, because I mean, glass fiber is extremely abrasive. So make sure that your hot end is, and I guess ultimately the nozzle can take those abrasive filaments. I mean, the heat break needs to be abrasion resistant, should be, but even if it's not, then you can probably print for a bit with it, but eventually it will wear out if it's not abrasion resistant.
Okay. Have you guys seen any wear issues or particle generation on the extruder side, on the gears from these abrasive filaments?
No, our gears are extremely hard, so they can take it all day.
Okay. And then what about like printing fast. So we touched a little bit about it, and like maybe motor size and not to go too small. On the extruder side, what does it take to print a material fast? What features do you need to have in an extruder if like you're looking for one to buy, and what do you need to make sure it has to make sure that you can actually hit those high speeds?
That kind of depends on what you mean by fast. Is it a fast XY movement, or is it a fast extruder gear rotation movement?
Well, I was thinking more in terms of just printing speed, actual laying down the filament and the XY motion being fast.
Yeah.
But as you go up, especially if you increase the nozzle size, like one of the things I want to play around with is having a larger nozzle for the infill. And so in that case, you'll get both. You'll get, the motion system moving faster and the spinning of the extruder moving faster just because it's pushing more filament now.
Yeah, I guess you need to kind of balance that when it comes to choosing your extruder. Because the small light extruders, I mean, they allow your motion system to operate really fast because you're putting less strain on the system. So you can do higher accelerations and higher attained feed rates on the XY motion platform. But it also comes down to what kind of volumetric flow rate are you trying to achieve? Is it like above 50 or 60 cubic millimeters? Then you might be better off sacrificing that low weight for a little bit more torque in those very high flow rates.
Okay, so it's kind of goes back to flow rate again, and really the speed of the filament gears, is it really limited by the motor then, or are there other things where you shouldn't spin the gears faster than a certain speed?
No, I mean we got plenty headroom when it comes to bearings and stuff like that. So you can spin them fast all day. That's completely fine. It all comes down to what your requirements are and which extruder can meet those requirements.
Okay. For the next question, then, I know like the Bondtech extruders. You guys are like the premium brand. And there's a lot of clones online that are like a fraction of the or much less. I wanted to understand more like when you buy a Bondtech extruder, like that price. The reason it's higher is because a lot of it also is probably in the parts themselves. So what do your guys' extruder offer at the higher price that the cheaper clones simply cannot, and like what kind of issues could you have as a result if you don't have those features that the Bondtech extruders have?
I guess the number
material stuff and choices and maybe finishings, things like that make a big difference that like in the pictures you probably can't tell the difference too much.
No, I mean when it comes to the actual quality of the clones, that's extremely varying. I mean some are extremely high quality and look very good and perform very good. A lot of them though they use like way softer metal in the gears and they wear out super fast. The teeth maybe aren't as sharp. The machining isn't as good. They introduce more surface artifacts. But I guess what it all comes down to is if you want to support innovation and have us do cool new stuff, then if you buy clones, then you kind of sacrifice that, I would guess. Mm-hmm. And also, we pride ourselves on our great customer support. So if you have problems with an extruder or with an upgrade kit, and you contact our support, then you'll most likely be placed in touch with the engineer who designed it. So we can offer very close and relevant support.
Okay, nice. And I know like I haven't experienced this with extruders, but like the material hardness is a big deal. I know that I was working on a few projects in the past where there was some oversight and a softer material was chosen where there was actually some contact, and like after like a few thousand cycles, the amount of wear and particles was insane. So I guess if you're like printing reliably, if you want to print reliably and consistently, then it's like a no-brainer. Then I would even think it's probably costs more to replace clones than if you're like a print farm situation than just to buy the right one and before.
Yeah, and I mean a botched printer job causing a missed deadline. I mean that can cost a lot more than a single extruder.
Mm-hmm.
For sure.
Okay. And I guess for a final question from me, what are like the biggest challenges do you see, in the near future with extruders? Like, what are some big challenges that extruders need to overcome? And maybe like if you can give some insight into what's coming down the pipeline for the next wave of innovation. Like, I understand there might be some IP issues, so I'm not probing IP, but like anything you can speak to.
Yeah, I can't really say too much of what we're developing right now, but trust me when I say we are developing stuff, and it's very cool stuff, and you will get to see them fairly soon. And I mean, I guess that ties into it. I mean, what we need to do is to stay relevant and to bring in new cool stuff, and to bring in better stuff, smaller stuff, lighter stuff, more easy to use stuff. I mean, that's what it's all about, aside from the reliable extrusion part, I would guess.
Okay. What do you see like on the, maybe further from the extruder, like in terms of the FDM 3D printing machines themselves? What are they kind of the biggest challenges they're facing that they want to overcome in the next like a year or two? That, obviously the extruder might be a part of the solution. Because it seems like in the last year or so, we had like the Bamboo Lab really kind of, I don't want to say revolutionized, but really made the 3D printing a lot more accessible to the masses in ways that hasn't been done in the past. I mean, it seems like it kind of almost plateaus maybe from now, but I was wondering what's after that, what are we trying to get to after that plateau?
I mean, the printer, I guess, it needs to become an appliance that everyone can use. And why shouldn't it be? I mean, what Bamboo has made for the industry is huge, and it forces everyone to get on their feet and make the best stuff they can. I mean, the innovation wave we're seeing right now, it's huge, and it's in part thanks to Bamboo Labs, because they're forcing everyone to be better and to do better. I mean, just hours before this chat we're having now, Prusa released their new Core XY machine. It's very exciting to see how that's going to live up to all expectations.
Oh, I need to take a look at that. I haven't seen that yet.
Yeah.
Okay, well, I guess that's encouraging. It's not going to be a plateau here. There's still a lot of ideas and challenges that are being worked on.
I think we got more healthy competition now more than ever before.
Heated chambers and extruders. Any other considerations that is important to look at? Like, I've converted my maker gear with a heated chamber, and I've actually had to upgrade the material on the hot end to an Ultim piece, just because the other one, the PETG one, was just getting too soft and not adding grip. What have you seen in terms of having an extruder in a heated chamber, and what's critical to make it a reliable extruder?
First off, you need to make sure that your motor isn't running too hot, that you're burning your windings or any connectors and stuff like that. There are ways to deal with that, I guess. If you're running a really hot chamber, you can always add water cooling to your setup to keep things a little bit more chilled. But most of our extruders, like in the higher segment, like the LGX Lite Pro, the LGX Pro, and the LGX Pro Metal, they can all go up to very close to 100 degrees chamber temperature, as long as you monitor the motor temperature and make sure to lubricate your motor gears often. And if you want even more demanding applications, then we have, like I touched on this, the LGX Pro Metal, and that's fine even without cooling, up to 140 degrees chamber temperature.
Oh, wow.
So if you're going even higher, then add water cooling to that, and you're fine.
Okay. So really it goes down to going to metal, lubricating your gears frequently, and then cooling the stepper mode.
Yeah.
Okay, cool.
That's it.
Well, maybe with that, maybe you can wrap up by giving like an overview of some of the products that Bondtech is offering. I know you mentioned a few, but anything else you wanted to add and what Bondtech offers, and if we wanted to get an extruder, what's available?
Yeah, so I guess what we didn't touch on really that we make, which is changing the 3D printing landscape in a pretty good way, I would say, is the CHT nozzle. The CHT nozzle is a technology which has 3 channels and a sharp filament splitter at the inlet. So as you feed filament into this nozzle, it splits it into 3 channels, into 3 threads, I would say, and heats it from the inside. So you unlock up to 100% almost, but at least 30% more flow rate using the same hot end. And you have significantly less stress in the filament and a little bit more linear extrusion over different flow rates. So I would say check that out. And we're approaching Black Week now, and we will offer from 15 to 30% discounts on our CHT nozzles and some extruders and upgrade kits as well.
Oh, nice. Do you guys, like, when you're using it, if you're like swapping out filaments, is there any issues with removing all of the remaining filament, or does it tend to like come out or clean out once you put new material in?
If you do cold pulls, they look really funny because they have like a 3-prong at the end. So you can do that. It's completely fine. I would say if you swap from a high glass transition material to a lower one, maybe try and purge it at slightly elevated temps. But personally, I haven't ever had any issues going from one material type to another.
And is it also compatible with like carbon filled and glass filled filaments?
Yeah, we have the CHT bimetal for that, which uses hardened vanadium steel, which is extremely durable, and it can be used up to 450 degrees without losing the hardness.
Oh, nice. I'm going to go check that out.
Yeah,
the deal sounds tempting.
Yeah.
Anything else any other products that you wanted to bring up?
That's pretty much it. But keep an eye out in the next few months, and you might see something very cool.
All right, will do. Yeah. Well, thanks so much, Olof. I really appreciate the time that you have given us, and you give some education and educated me on extruders. And I've been in the 3D printing community enough, but not enough to really dive deep into the individual components. So I found this really helpful. And once again, I really appreciated the support in the past, and look forward to what you guys come up with in the future and anything else that we come up with in the 3D printing community. So with that, have a great evening. Have a good night's rest, and blessings to you for the next week.
Yeah, you too. Thank you for this opportunity, Andre. Hope your future endeavors into this goes as well as this did.
Thank you. Appreciate that.
Thank you.
Bye-bye.
Bye.